Dear friends, today I am going to explain the load line analysis of a PN junction diode. Okay. So this is a battery. The negative terminal is going to be grounded, and to the positive terminal a PN junction diode is connected, and to the negative, to the N of the PN junction, to the N semiconductor of the PN junction is connected with a load resistance, resistor, which is capital R. And second terminal of this resistor is connected to the same earth potential. Now, the potential of the battery is big E, positive, negative. Now, what happens when the current flows, okay, and it passes through the PN junction diode? Then a voltage develops across the PN junction diode, and that voltage we call it VD. Diode current is flowing. So this resistor R is also passing through the resistor. When the current will pass through this resistor, then there will be voltage across the resistor by Ohm's law. The current ID into R, that voltage becomes VR. So, because the current is flowing along this direction, so a voltage develops across the diode with positive end here, negative end here, and voltage develops across R, positive end here and negative end here. The voltage across the diode VD and the voltage across R, which is VR. The two voltages are because of the big E. So part of E develops as VD, and part of E becomes VR. So E is actually VD and V are actually made up of VD and VR is actually made up of E. So E is equals to VD plus VR, which is IDR. Now IDR, okay, can be written as minus VD plus E. Dividing each term by capital R. Now just comparing this equation with the equation of the straight line, y equals to mx plus c, where y and x are the variable, m is the slope, and c is the intercept. Now just comparing with our equation, so instead of y we are having id, instead of x we are having vd, and big E over R is C, and minus 1 over R is the slope. That means if we plot a graph between ID and VD, ID means Y, VD means X. So that will be a straight line. Also, because negative sign is here, the straight line will not be of this like this, because this line is having positive slope. The straight line will be like this. It is having a negative slope. So we are having this line because the minus sign is here. So if you plot a graph between ID and VD, that will be a straight line with negative slope. Okay, straight line equation with negative slope. So we are going to draw a load line. How? For load line, we'll draw a graph between VD versus ID. Voltage across the diode and ID. So this is a negative slope. Now first of all, if VD equals to 0, where the VD is 0. Like we are coming along this side, VD decreasing, and here VD becomes 0. And when VD becomes 0, what happens? ID becomes E over R. When VD is equals to 0 at here, ID becomes, the diode current becomes E upon R. So let E upon R is this point. Okay. Now secondly, if ID equals to 0, now you put ID equals to 0 here. And what happened? This becomes, this term, the total term becomes equal to this term. Okay. And then we find the value of VD. R and R cancels out, and VD becomes equals to E. Just see. So VD becomes equals to T. Now where the ID is 0, we are coming along this side. ID decreasing, and here becomes ID 0. And ID 0, but with the value of VD then, it is E. Let that E value is, suppose E value is this point. Okay. So joining the 2 points, when we join the 2 points, we are having a line. And this line is called load line. Now you may ask a question, why it is called the load line? Because its slope depends upon the external resistor R, which is called a load resistor, which we call a load resistor. Okay, this slope, its value depends upon this R. So that's why its name is load line. If you change the value of R, the slope will change. Okay. Now this curve, this is a diode characteristics curve. But keep in mind, this characteristics curve is the graph between the applied voltage versus the diode current. Okay, this is the load line. Now one thing is very important. The load line cuts the characteristics curve at this point. At this point. This point is very, very important, called the Q point. Now according to the Q point, what is, we draw a perpendicular on the VD axis. So we draw a perpendicular, that is the VD, diode voltage. And that is the diode current for the Q point. The load line cuts the characteristics curve at this point. Okay, for a particular PN junction. You may have any PN junction, but characteristics curve, it differs of one PN junction to the second PN junction. But for any particular PN junction, the load line cuts it at here. So according to this point, to a perpendicular on this line, to a perpendicular on this line. That becomes diode voltage for the Q point. According to the Q point, diode current according to the Q point. Let an example, we are having a PN junction diode, then a battery, terminal is grounded, resistor R, and this is the resistor R, which is having 1 kilo ohm value. The current flowing is ID. So the battery is of 10 volts and we call it E. And across the diode voltage is VD. Now this is our characteristics curve, diode characteristics curve. 1 kilo ohm is the resistor, external resistor, mean the load resistor, silicon diode, and 10 volt battery. The question is, what is VDQ and IDQ for this particular diode? Given a characteristics curve here. And second question is, what is VR in this problem? So first of all, we draw a load line, and I already explained that what is the value of ID when VD is equals to 0, then it is E by R. And what is E in this particular problem? 10 volt. And what is R? 1 kilo ohm. So ID becomes 10 milliampere. So this is one point for the load line. 10 milliampere. Now for the second point, we make ID 0 and then VD becomes equals to capital E. What is value of capital E? That is 10 volt. This is the second point. With these 2 points, we draw then a load line. Now this scale, we cannot use this scale because it is only up to 0.5, 0.8, 0.9 volt. We need here the 10 volt. So I'm going to redraw the characteristics curve. This is a scale now along x-axis. Along x-axis, I've chosen 2 volt, 4 volt, 6 volt, 8 volt, 10 volt, like that, up to 10, because we are having 10 volt battery. And that is one point. Now along the y-axis, the current, okay, and we are having current how much? 10 milliampere maximum. So selecting the 2 points. So this is first of all the characteristics curve, and now this is our load line joining the 2 points. Now then look, draw perpendicular, one along x-axis, other along y-axis, where the load line cuts the characteristics curve. So draw a perpendicular, exactly perpendicular. In this case, it is very near to 1 volt, where it cuts the x-axis. Is exactly VDQ, we call it VDQ, is 0.78 volt. And second, we draw the perpendicular on the y-axis and let it is 9 milliampere. I am not exact, but roughly let's say it is 9 milliampere IDQ. So this is our load line, and VDQ and IDQ, the value comes 0.78 volts and second the 9 milliampere. Now we find the value of what? What is the voltage across the resistor R? Is equals to IR into the resistor, or you can say the ID into R. And it is, IDQ point. IDQ into R, it is 9 milliampere multiplied by 1 kilo ohm. Now kilo and milli cancels out, that becomes 9 volts. So there's value of the voltage across the